Hi, and welcome to the video on how to complete Part 1 Blackbody Radiation Diagram and Part 2 Hertzsprung-Russell or HR diagram. So for Part 1, we're going to use a PhET simulation of blackbody radiation spectrum to determine the relationship between the temperature of an object and the color of light it emits or gives off. So on this handout, you will see you have a partial electromagnetic spectrum. And at this point, you should know what an electromagnetic spectrum is. It shows all the ranges of different types of light based on their wavelength, frequency, or energy. And in this partial electromagnetic spectrum, you'll notice that the energy increases as you go to the left. So on the left side, you have higher energy light, and on the right side, you have lower energy light. At the bottom of the partial spectrum, you have the wavelengths, and they're given in micrometers. Now we can use this to help us if necessary. It'll also be used to answer at least one of the questions. Now, to get to the blackbody spectrum, you would click on the PhET link either in this document or the PhET link in your Schoology folder if it's there. So if you're going to the Schoology folder, you click on that. Remember, you have to pop it out, hit continue, and then you can press play. Or you can click on the link that's in the document. Now, when you get to the simulation, take a moment to look at what you have here. So you'll notice that you have a plot of blackbody. It's a blackbody radiation spectrum. And whenever you have a plot, you always look on the Y and X axis. On your Y axis, it says spectral power density. That's like the intensity or brightness of light. On the X axis is the wavelength. And you'll notice that the shape of the graph is sort of like a hill. So it has a top part, which is your maximum part of the maximum amount of emitted light for an object. That's what we're going to focus on. Now to get set up, we're going to click on graph values so we can see the value for the X axis. That tells us the wavelength at the maximum amount of emitted light. And then we're going to click on labels because that'll help us to know what part of the electromagnetic spectrum we are in. So as you can see here, this side is ultraviolet, in the middle is visible, and then the right half is infrared. We also have a thermometer, which has different objects. Sirius A is a star, so is the sun. Then you have a light bulb, and then you have Earth. And those different values what you can do is you can move this blue triangle to figure out the temperature of those different things. All right, so we're going to start at the sun. We're going to do that one together, and you're going to see how we record the data. In your table, the data that you have is the temperature. So you have the object, of course. Two of them, they don't have object names. They just have a temperature. The object, the wavelength of light that's emitted at the peak, and then the color of the object. And again, what we're trying to do is see the relationship between temperature and color. So as the temperature increases, what happens to the color of light that's emitted? Is it more blue? Is it more red, for example? So let's start off at the sun. We're going to do that one together. And then I'll show you how to do these two, which don't have an object name, but just have a temperature. So going back to your blackbody spectrum, sorry. Close some of these things down. It's already set on the sun. And the first thing we're going to record is the temperature. This is 5,850. K stands for Kelvin. It's a unit of temperature like Fahrenheit or degrees Celsius. So 5,850 Kelvin is what we're going to type here. Or you're going to write it on your handout. So go ahead and write that down. Now we're going to get the wavelength of light. So for the wavelength, because we have the graph values already placed, you're just looking at the x-axis. And the wavelength I have here is 0.495, and that's micrometers. So you're going to write down micrometers. It's kind of like a U with like a little extra line going onto it, but that's what you would type it. That's what you would write down on your paper. Don't forget your units. Then it says color of object. All right, so that's where you're going to utilize, you can utilize one of two places. You can see where the peak is in the spectrum here. So you can see that the color here is sort of like a greenish, it's like in the green range, greenish blue. And so you can type that in or write that down that way. The other thing to do, which is what I would recommend, you see it says 0.495. You're going to go back to this chart and figure out where 0.495 is. So 0.495 is kind of in the bluish range here. Okay, it's at the end because it's between 0.425 and 0.52. So if you're doing it from the spectrum, you would read it as blue-green, because that's where it's kind of like in the blue-green range. We call that cyan. Or you can use the lines here. So either way, so either you're using this spectrum or you're using what you see there. All right, let's look at an example where you don't have an object, you're just given the temperature, like this one says 550 K. Well, what you're gonna do in that case, you could ignore the object, you're just gonna move it until you're at 550 K. So since it's 550 K, that means the temperature is lower. And you're gonna try and get there as best as you can. Wait, let me just double check the value. Oh, 5050, okay, 5050 K. So I gotta go even lower. Then once you're there, you can type in the wavelength, and the temperature is already given to you. So that's your wavelength. And then you can use that to figure out what color it is, either from here, which kind of looks like yellowish, or you can use this here. All right, so once you've done that, then you can answer the questions. And to answer the questions, you may need to use this as well. So that's how you complete part one. Part two, which is the Hertzsprung-Russell diagram, it's pretty simple. These are just questions using the Hertzsprung-Russell diagram that you've copied in your notes. So before you get to part two, you have to have the notes copied down. And you also are going to watch a video on the Hertzsprung-Russell diagram. The Hertzsprung-Russell diagram is a way that we classify, or we use it to sort of classify different types of stars. And you'll notice that there's a band here, we call that the main sequence. Above the band, we have red supergiants and red giants on the right-hand side, and then we also have blue giants on the left-hand side. And that's because the blue giants are at a much higher temperature. Temperature increases as you go to the left than the red giants. Then you have white dwarfs underneath, and you'll notice that the x-axis has your temperature, the y-axis has your brightness. So using the information here, you're going to identify or answer the questions. So you're just kind of using your graphing skills. So for example, this first question says, which types of stars are the hottest and brightest? Well, hottest, as you can see, will be going to the left, and brightest will be going up. So what type of stars are in the upper left corner? Those are blue giants, so that's what you would type there. Now, when they give you a specific star, like they tell you it says a temperature of 30,000 Kelvin, a luminosity of 10 to the 6, and they want you to know what color the star is and what type of star it is, you have to find that point on the graph. So 30,000 Kelvin and 10 to the 6 lumens, which is the brightness. So 10 to the 6 lumens is up here, and 30,000 Kelvin is between these two. So find out where that is, and then figure out the type of star and the color of the star. All right, I hope you found this video helpful on how you will complete those questions. Have a quality day.